Hello students, now in this video let's see the next function of number theory, that is arithmetic or number theoretic function. Number theoretic function. Now, what does this? Let's see the definition of it. The definition: any function whose domain is the set of positive integer and codomain is the set of complex number is called arithmetic function. Now here we define following arithmetic functions. Now what they are? Arithmetic, capital A. Okay. Now what they are? Now look at, first of all, let n be any positive integer, because the domain should be the set of positive integers, so input should be a positive integer. N be any positive integer, then first thing, dn. What is dn? It is number of positive divisors of n. Number of positive divisors of n. Second, sigma n. Sigma n is what? Sum of all positive divisors of what? N. Sum of all positive divisors of n. Then sigma kn. What it is? It is sum of kth power of all positive divisors of n. Positive divisors of n. Obviously this k should not be 1. If 1, then it is nothing but sigma n. If k is equal to 2, then we will take the square of each divisor and we will take the sum of it. Then if k is equal to 3, then we have to take the cube of all divisors and sum of them. Okay, as such sigma k n. Now fourth, omega n. It is the number of distinct primes dividing n. Various primes, which are they? We have to take the count of them. number of distinct primes which divides this n. So while finding divisor, after finding divisor, we have to count the primes of them. That will be our omega n. Then next one, this is capital omega n. Capital omega will be number of primes dividing n. Now number of primes dividing n, but here we have to, these are the primes here, we have to count multiplicity of them, counting multiplicity. Then next one, phi of n. Phi of n is number of positive integers less equivalent and that are relatively prime to n. That are relatively prime to n. Okay. Now these are nothing but the arithmetic functions we have to look here. Now let's see some examples on these one. Remember this d of n will be number of positive divisors of n. Sigma of n will be sum of all positive divisors of n. Simply divisors we have found, we have to take a sum of them. Here we have to take kth power of these divisors and take a sum of them, that will be sigma k of n. Omega n will be number of distinct primes. Among these divisors we have to count primes here. Capital omega n will be what? We have to count multiplicity of these primes. Phi of n is known to you, it is Euler's phi function. That will be number of positive integers less equivalent that are relatively prime to n. Okay, so let's see some examples on this. Example, let n equal to 12, then the positive divisors of 12 are what? 1, 2, 3, 4, 6 and what? 12. Therefore, what we get? D of 12 is equal to how much? 6. Again, what is sigma 12? Sigma 12, D of 12 is 6. Why? Because these are the divisors. So, that is equal to 6. Now, sigma 12 will be what? The sum of these. So, 1 plus 2 plus 3 plus 4 plus 6 plus 12. How much is this? This is 28. Now, suppose we have to find sigma 2 of 12. So, we have to take the square of these. So, 1 square plus 2 square plus 3 square plus 4 square plus 6 square plus 12 square. So, it is 1 plus 4 plus 9 plus 16 plus 36 plus 144. So, that is equal to how much? 210. Again, here 12 can be written as 4 into 3. That is equivalent to 2 square into 3 raised to what? 1. Therefore, omega 12 will be what? How many distinct primes are there? So, sorry. Here how many distinct primes are there? Only 2. That are 2 and 3. So, 2, let me write in bracket, 2 primes are there. 2 primes, 2 and 3 are there. Fine. 2 primes, 2 and 3 are there. Then next, suppose capital omega of 12 we have to find. So, capital omega of 12 will be how much? 3. What does this? This is nothing but how many times these primes occurs. This can be written as 2 into 2 into what? 3. So these primes, whatever this prime occur twice, so that 2 plus this one occurs once. So 2 plus 1, that will be 3 here. We have to count the multiplicity of them here. So here I can write in a bracket for your understanding how many times primes occur. This is for your understanding I had written, not necessary to write. Now here 2 occurs twice, 3 occur once, and we have to take sum of them. 2 plus 1 will be what? 3. Or let me write here, 2 plus 1 will be what? 3. Now the another, what is 5? Now look at these divisors. Now this 5 is nothing but some numbers from divisor, but 5 is actually the numbers which are less equal to 12 and relatively prime to 12. So here 1, 5, 7 and 11 are positive integers less equal 12 and relatively prime to 12. Therefore, pi of 12 is equal to how much? 4. Now, let's see one more example of the same kind, or 2 or more. Let's see. Okay, this is about these functions, how to find their values and all. Now, let's see some more examples. Suppose now n is equal to 13. So for n equal to 13, let me find all these 1. So the positive divisors of 13 are 1 and 13. Okay. Therefore, d of 13 equal to how much? 2. What is sigma of 13? Sigma of 13 is addition of these 1 plus 13, so that will be how much? 14. Now sigma 2 of 13, so it will be 1 square plus 13 square, so it will be 1 plus 169, that will be 170. Here 13 equal to 1 into 13 only. How many primes are there? Only one prime. So omega of 13 will be how much? 1. Then again this capital omega of 13, that is counting of these primes, so it is also 1. Only one prime. 1 is neither prime nor composite. So 13 is the only here. Then phi of 13. What is phi of 13? 13 is a prime number. So phi of 13 is how much? 12. Already we have seen some results for finding phi. These functions are new for you only. Try to solve various examples on this so that you will be perfect in that. Now let me take one more. Now let n equal to suppose 24. If n is equal to 24, the positive divisors of 24 are 1, 2, 3, 4, 6, 8, 12 and what? 24. These are the positive divisors. How many are they? 3, 3, 6, 2, 8. So therefore, d of 24 is equal to how much? 8. Now sigma of 24 is equal to 1 plus 2 plus 3 plus 4 plus 6 plus 8 plus 12 plus 24. So that is how much? That will be 60. Then sigma 2 of 24. So that will be 1 square plus 2 square plus 3 square plus 4 square plus 6 square plus 8 square plus 12 square plus 24 square. So it will be 1 plus 4 plus 9 plus 16 plus 36 plus 64 plus 144 plus 24 square will be 576. So this sum is how much? 850. Now suppose omega of 24. What is omega of 24? Now for that we have to factorize 24. 24 can be written as 8 into 3. So 8 can be written as 2 cube into 3 raised to 1. So how many primes are there? Only 2. 2 and 3. In factorization 2 primes. So 2 primes are there. Now capital omega of 24. Capital omega of 24, how many times these occurs? So 2 occurs thrice and 3 occur once. So we have to add these ones. So that will be how much? 4. Now what is phi of 24? You know the formula for finding or the rule for finding phi of 24. It will be 24 into 1 minus 1 by 2 into 1 minus 1 by 3. So it will be 24 into 1 by 2 into 2 by 3. So it will be 6, 6 4s are. So 4 2s are how much? 8. So phi of 24 is how much? 8. Now just before this example we had taken an example for a prime number. Now let me write one remark. If p is a prime, what are the values of these all functions? So you can compare that remark with that example of n equal to 13 we had taken, just an example. So let me write remark 1. Suppose if p is prime, then d of p is equal to 2, sigma of p is equal to p plus 1. Then another one, omega of p, both omega are here 1. This capital omega also what? 1, because only one will be there. Then phi of p is known to you. Phi of p is what? P minus 1. This is the remark. Okay. Now let's take some more remarks. Suppose remark 2. Remark 2. Summation f of d, where d divides n, means that the sum of f of d over all positive divisors of n. We will take examples on this so that you will get it. This means the sum of f of d over all positive divisors of n. So here we have to find divisors first. Function is given to us. We will find the value of function there and we will take the sum of that value of function here. Positive divisors of n. Okay. Now remark 3. Remark 3. Okay. What does it? Using remark 2, we can write d of n will be summation d divides n 1. Function will become 1 there. For sigma of n, summation d divides n, it will become d there. Whatever d we have to add there. Fine. Then sigma k of n, that will become summation d raised to k, d divides what? N. Okay. Then omega n, what is omega n? It will be summation p raised to alpha divides n, here we get 1, or summation p divides n, we get a function will be what? 1. All primes we have to take only here. Okay. Then capital omega of n, that will be product of what? These alphas. P raised to alpha divides n. So we have to take product of these alphas. Indices we have to take only. Okay. Now let's see next one more remark. Remark 4. Remark 4. Now let n greater than 1 be any integer then n equal to p1 raised to alpha 1, p2 raised to alpha 2 and so on up to pr raised to alpha r. So on up to pr raised to alpha r, where p1, p2 and so on up to pr are distinct primes. Then all positive divisors of n are those integers m are of the form m equal to p1 raised to beta 1, p2 raised to beta 2 and so on up to pr raised to what? Beta r, where 0 less equal beta I less equal alpha I for all I going from 1 to so on up to what? R. Now let's see example here. Here n will be written in a prime factorization. So positive divisors are n are those integers m are again of the form the prime factorization. Obviously here beta is what? Less equal alphas and greater equal what? Zeros. It will happen. Obviously this is happen. Now let's see example. Let n equal to what? 50. So 50 can be written as 2 into 5 square, 2 raised to 1 5 square. Then positive divisors of 50 are of the form m equal to 2 raised to beta 1 into 5 raised to what? Beta 2, where 0 less equal beta 1 less equal 1 and 0 less equal beta 2 less equal what? 2. If beta 1 is 0, then m equal to 2 raised to 0 into 5 raised to what? Beta 2. Okay. So it is 5 raised to beta 2 only. And what is beta 2? It is 0 less equal beta 2 less equal what? 2. So beta 2 having a value 0, 1 and 2. Therefore m equal to how much? 1, 5 and what? 25. Again if beta 1 is equal to 1, then m equal to 2 raised to 1 into 5 raised to what? Beta 2. So it will be Again, the range of beta 2 will be same. Range of beta 2 is same. Fine. So, here, therefore, what is m? M is equal to beta 2 is 0, then m is 2. Beta 2 is 1, then m will be 10. And beta 2 is 2, then m will be how much? 50. Thus 1, 2, 5, 10, 25 and what? 50 are positive divisors of what? 50. Now 50 is a very small number. We can easily determine these positive divisors of 50 orally also, but this is a way for finding positive divisors of that number for a large integer. So now let me take one more example of that kind. So while finding positive divisors, then and then we can find out easily the other functions. First of all, we need to find d of n. How many are they? Positive divisors. So here they are how much? 6. Therefore we can say here d of 50 is how much? 6. Then sigma of 50 will depend on the same. So that's why this is a way for finding these, or this remark is useful for that one. Let me take one example of that kind so that it will be clear to you. So let's take an example for some slightly large number. So example, let n equal to 180. So here 180 is equal to 2 into 90. So it will be 2 into 3 into 30. So it will be 2 into 3 into 2 into 15. So it will be 2 into 2 into 3 into 3 into what? 5. I had taken this 2 before. Fine. So that is same as 2 square into 3 square into what? 5 raised to 1. So alphas are 2, 2 and 1, or you can say beta also. Therefore m equal to 2 raised to beta 1, 3 raised to beta 2 and 5 raised to what? Beta 3. Where 0 less equal beta 1 less equal what? 2. 0 less equal beta 2 less equal what? 2. And 0 less equal beta 3 less equal what? 1. Okay. So now if beta 1 equal to 0, then m equal to 3 raised to beta 2 into 5 raised to what? Beta 3. So 0 less equal beta 2 less equal 2 and 0 less equal beta 3 less equal what? 1. So beta 2 is equal to 0, then m equal to 5 raised to what? Beta 3. So 0 less equal beta 3 less equal what? 1. So that gives m equal to how much? 1 and 5. Okay. Now beta 2 is equal to 1. Then m is equal to 3 raised to 1 into 5 raised to what? Beta 3. Where 0 less equal beta 3 less equal what? 1. So that will be how much? M equal to 3 and how much? 50. Okay. Now beta 2 is equal to 2. Then m equal to 3 square into 5 raised to what? Beta 3. So 0 less equal beta 3 less equal what? 1. So that will be m equal to what? 9 and 45. Okay, I am putting these values of beta 3. Now, if beta 1 is equal to 1, then m equal to 2 into 3 raised to beta 2 into 5 raised to what? Beta 3. Where or here 0 less equal beta 2 less equal to and 0 less equal beta 3 less equal what? 1. So beta 2 is equal to 0, then m equal to 2 into 5 raised to beta 3. Beta 2 is 0, then this will become 1. Okay. So 0 less equal beta 3 less equal what? 1. So that gives m equal to how much? It will be 4. Sorry. It will be 2. It is how much? 2 and what? 10. Okay. Then beta 2 is equal to 1. Then m equal to 2 into 3 into 5 raised to what? Beta 3. 0 less equal beta 3 less equal what? 1. So that is 6. M is equal to how much? 6 for beta 2 0 and beta 2 1, then it will be 30. Then next beta 2 is equal to 2, then m equal to 2 into 3 square into 5 raised to what? Beta 3. And what is beta 3? It is lies between 0 and 1. 0 to 1. So m is equal to how much? It will be 18 and what? 90. Okay. Now again, if beta 1 is equal to 2, then m equal to 2 square into 3 raised to beta 2 into 5 raised to what? Beta 3. So 0 less equal beta 2 less equal to and 0 less equal beta 3 less equal what? 1. Beta 2 is equal to 0, then m equal to 2 square into 5 raised to what? Beta 3. 0 less equal beta 3 less equal what? 1. So m is equal to 4 and what? 20. Then beta 2 is equal to 1. Then m equal to 2 square into 3 into 5 raised to what? Beta 3. 0 less equal beta 3 less equal what? 1. So m is equal to 12 and what? 60. 12 and 60. Now beta 2 is equal to 2, then m equal to 2 square into 3 square into 5 raised to what? Beta 3. So 0 less equal beta 3 less equal what? 1. So m is equal to 36 and what? 180. So we had taken all the values, and these, what are the values of m as these are nothing but our positive divisors of 180. So let me write the final answer here. Thus what are they? 1, 2, 3, 4, then 5, 6, then 6 onwards 9, then 10, 9, then 10, then 12, then 15, then 18, later on 20, 30, 36, 45, 60, 90 and 180 are positive divisors of 180. Therefore D of 180 are how many? These are 6, 6, 6. So it will be how much? 18. These are 18 in number. So this is our answer here. Now in next video we will see some theorems and examples on this one. Okay. Thank you.